Dear students, welcome back to physics class. Last day we studied about the Newton's second law of motion. Next we are going to learn about mathematical formulation of Newton's second law. So once more I will explain about Newton's second law. Newton's second law states that rate of change of momentum is directly proportional to the unbalanced force that is applied externally. Here we are going to change this Newton's second law into equation, that is in a mathematical form. Therefore, the first step is that rate of change of momentum. In that we are dividing this sentence, that is the rate of change of momentum is to change in momentum, and change in momentum to momentum itself. You know what is momentum? It is the product of mass and velocity. Therefore, P is equal to mv. This is the equation of momentum. What about initial momentum? Yes, I can write P1 is equal to mu, that is initial velocity u. Therefore, P1 is equal to mu. And what about the final momentum? Final momentum is P2 is equal to mv. The next step, that is from the Newton's second law, change in momentum. There is rate of change in momentum. Instead of that we are taking change in momentum. That is change in momentum can be written as proportional to change in momentum. Therefore, change in momentum is proportional to external force. Here I am writing change in momentum is P2 minus V1. We are putting the proportional sign, not equal sign. It is proportional sign, P2 minus P1. And you know what is P2 and P1? That is mv minus mu is proportional to mv minus mu. The next step is from the Newton's second law, rate of change of momentum. So here from the momentum we started, change in momentum we write. The next one is rate of change of momentum. I am going to write rate of change of momentum. Rate of change of momentum is proportional to, rate of change of momentum is proportional to mv minus mu by time. That is, we are including another physical quantity, that is time. So you know that from the mathematical formulation of Newton's second law, that is rate of change of momentum is proportional to unbalanced force. That is F, rate of change of momentum. Instead of we can write F is proportional to mv minus mu by t. Instead of that we can take m outside, that is v minus u by t. And you know what mv minus u by t? v minus u by t is already, it's familiar to you, it's acceleration. So instead of v minus u we can write acceleration. F is proportional to ma. But we cannot put the equal to sign. Instead of that, to put the equal to sign, the proportionality constant should be right. That is F is equal to kma. That should be noted. F is equal to kma. That is, there is a proportionality constant here. F is directly proportional to mass into acceleration. But there are so many factors, and that factors are included in a particular proportionality constant, and it is known as k. So we are all lucky people that k is equal to 1. The value of k is 1. Therefore we can write that famous equation, that is F is equal to ma itself. The mathematical formulation of Newton's second law. Thus we found out the equation F is equal to ma, mass into acceleration. We started from the momentum, then we write change in momentum, Then we write rate of change in momentum, and rate of change of momentum is proportional to unbalanced force. Therefore, F is equal to ma. We got it. And I want to say something. The unit of force is Newton. Then what will be the definition of 1 Newton? In your textbook it is clearly written. You have to read before coming to live session. And also you have to find out what is the importance of time in this equation. That is, we have to increase the time to decrease the effect of force, or decrease the time to increase the effect of force. These all things are written in your textbook. That also you have to read before coming to the live session. And thank you all of you for listening to this class. We can